Okay, so this meeting will be about luminescence, and here's a little pun that I made. So luminescence is defined as the light emission by any substance without heating, and the other one is incandescence, which is with heating. So like those incandescent bulbs, the ones that get really hot. So there's a few common types, but today we'll be talking about two of them, which are chemiluminescence and photoluminescence. Chemiluminescence is the emission of light from a chemical reaction, and photoluminescence is the emission of light from like a light source, so photons. So chemiluminescence, there's a general like equation thing. There's A plus B is C asterisk, and the C asterisk is like you can sort of think of it as like a transition state where like A and B come together, form a really unstable intermediate, and it's that unstable intermediate that eventually decays into its stable form. So C, like the regular C, plus some light. One of the reactants is a fluorescent dye, and the other is usually something that initiates the reaction. So like for luminol, we'll show that later, it's hydrogen peroxide, and for glow sticks, it's some sort of like ester. And what these have in common is they have a oxygen-oxygen bond, and oxygen-oxygen bonds are generally super unstable, like single bonded oxygen to oxygen. So it's really easy for it to like split and for electrons to move around. So that's perfect for this because you don't want the electrons to jump into the molecule and just get released soon. There's an unstable state, and some applications are glow sticks. We'll pass those around in a minute. Bioluminescence, it's where like usually it's in the sea. You see like those what is it called? The fish with like the dangling light. Yeah, anglerfish. Yeah, they do that. And forensics. So what happens in forensics is they use luminol to see where blood has been. So there's iron in blood, and the iron in the blood catalyzes the reaction between the luminol and the hydrogen peroxide, so you can see it glowing. So like in this picture, you can see this is like a regular image, and this is it with luminol under UV light. You can see it starts glowing where the blood is. Does everyone have a glow stick, or is everyone in proximity to a glow stick?
Yes.
I'll just explain how like the basic thing behind glow stick. So in the tube, there's usually there's like an outer liquid and an inner liquid in like a glass tubing, and I took some out like right here. So what happens is when you break it, the inner liquid is usually a fluorescent dye. It travels to the outside, and in the outside is the phthalate ester and usually hydrogen peroxide. So when you break it, the two like mix, and that's what makes it start glowing. So you guys can start breaking it. You can hear the crack of the glass when you break it. So like shake it up so you can mix it. Yeah, they're pretty bright.
There we go.
Shake it around again.
Yeah, mix it around.
What's swole?
Yeah, look, I'm Shrek. Look.
Okay.
Get out.
Okay. So the next one is phosphorescence. Phosphorescence is not luminescence because it doesn't immediately re-emit the light. So you can see these in like most watches have dials that are glow in the dark. It needs to be it's like there's some weird quantum mechanical stuff, but it basically needs to be charged first, and it emits it over a long period of time, usually like minutes or hours. So you can use it in like there's like glow in the dark tape, watches, toys, and some spectroscopy stuff. All of these things can be applied in spectroscopy, just there's a different like variation on it. Okay, so this is like a toy that I found in my drawer. I haven't opened it in like a long time. So the foil is to prevent any like light to hit it. So right now, so I'll unwrap this. and it's not really glowing, right?
Yeah.
But when you charge it up, and you usually charge things with these, so like turn these on. Sorry.
So what are those making?
What?
What are those?
Okay, these are black lights. They emit really high energy photons, which can translate into these. So now you can see it starts glowing. And if you have like a really concentrated source, let's see, you can like, this is a beam, so like one of these, but in a thing, so you can make it glow really bright like that.
can recharge these glow sticks if you wanted to.
No, there's a
No, yeah, they're not phosphorescent. But yeah,
Hey, yeah. I thought I was.
Hey, sorry.
so yeah, this is phosphorescence. If you have a watch, the dials usually have little glow-in-the-dark things on it. So our last one is fluorescence, which is the most exciting, in my opinion. Like I said, for phosphorescence, it emits it over like a long period of time. But for fluorescence, it's immediately emitted, or they call it immediately, but it's like a few nanoseconds, basically immediate. And something to take note is the light that's emitted is usually lower in energy, which means it's higher in wavelength. And you can see this is the emission spectrum for fluorescein. The dotted line shows what it absorbs, and the solid line shows what's emitted. And you can see the peaks are slightly shifted. And here's a diagram. This is a Jablonski diagram. It just basically shows like the energy states, so this is 1 energy level, this is 2, this is 3, 4. You shine a light at something, and it excites an electron, right? The electron absorbs the energy. What happens is all molecules have some sort of movement. So when it starts moving, when it starts vibrating, it loses a bit of that energy through the vibration, and then it jumps down. So that's why the energy that's re-emitted is always usually lower than what you put into it. And we generally use like black light, UV light, because it's like high in energy, low wavelength, and it's not too visible to the human eye. So it's cooler when you like see something glow from this. So we go back. Some applications. So for like the organisms again, there's biofluorescence, which is almost the same thing as chemiluminescence, but like when light shines on it, it glows like fireflies. Fluorescent lamps. These lights and like the usual fluorescent lamps they all have mercury usually in them, and they have something called phosphor. So when a high voltage is applied to it, it excites the mercury, and the mercury ions like release some energy. And the phosphor is the dye that is what's it called? That's like lighted. So the white light that you see is the phosphor glowing. They use this in LEDs too. So when you have like LED, it's usually white. And like right here, this is like an epithelial cell, and you can see there's blue, there's green, there's orange. So you can like track certain things that you put into it, and you can use it as a tracer. For fluorescein is fluorescent, but it's really non-toxic. So sometimes when you go to the eye doctor, they give you like a fluorescein drop in your eye to see if you have any like cornea damage. So these are, oops, let me turn these off. So under normal light, they're pretty colorless. You can't really see anything. If you take, let's see, where's the, okay, this is the UV light, right? If you shine it through here, you can see all the different colors. So these are 4 different fluorescent molecules, and they all emit a different wavelength. Like I said, with the light that's emitted is usually lower in energy. If you use green light is lower in energy than blue light. So if you use green light, only some of them light up. So like this one, you can see it lights up, but these, they don't really. And for red light, none of them should light up. There's like a little beam because there's a few like particles suspended, but it's not. Yeah, they usually don't light up. So this is just the same thing, but you can see it. It goes. You can bend it a little bit.
I would take a little bit.
I got most of these from highlighters, by the way, so you guys can do this at home.
How do we extract it? Ruin your highlighters.
Just take it open. Yeah, squeeze. Yellow highlighters usually have something like this. This is fluorescent, and you can see it goes really bright.
Oh, we'll make a lightsaber.
Let me turn these on.
Hey, Michael, do you know if lightsabers are fluorescent?
I don't think they are. I don't know yet. I don't know Star Wars lore, so.
Michael, what are your opinions?
You can see it starts glowing.
What are you doing?
Okay.
Whoa.
This is water. But okay. Yeah, this is fluorescent. This is really concentrated fluorescent. You can see it's like sort of red.
Yeah, dang.
Here we go.
So
Explosion.
I'll just take some.
Is it gonna be like a
It's gonna be an explosion.
something like streaks?
Alright, come on, Michael.
Here, I'll move this closer. You can see it better.
Oh.
You should.
Whoa.
You got to get a drink out of
Huh?
Are you gonna do this circle?
No, it's you can just look at it like this.
The camera's rolling, that's awesome.
Yeah, you can play with this.
We'll get like the smoke ring.
I'll make sure
Like
to add
that one.
explosives.
See how it made like a smoke ring?
Yeah. Let me see if I can do one. Hold on. Yeah, I can't do it. I'll wait a little bit and then just add the whole thing. Take some more.
Go ahead and have another kid.
Mr. Wilkins.
How long is this match?
That kind of reminds me of like
Yeah, you can all the 50 feet.
egg cups. It's not like egg
Okay.
cups. No,
I'll pour some in.
Whoa! Missed it. You guys aren't paying attention.
I'll set this aside. See, the further away you move it from the light, it gets a little bit dimmer.
Wow.
That's just because of the intensity. This is just another thing. This is tonic water. You can find this like at anywhere, pretty much.
Well, can you steal mine?
Yeah.
You've stolen everything.
It's like seltzer water, but there's quinine in it. Quinine, yeah, however you pronounce it. Quinine. Quinine is fluorescent. So again, this is the blue light. If you want to see it, this is pretty cool. This fluorescent. This is unopened, by the way. You can come here and see it if you want.
We don't trust us.
But yeah, if you can turn these on.
Oh.
Move it here.
Party tricks.
Yeah.
Wow.
Yeah, these are usually at parties.
Yeah, soda water is never mind. Shut up now.
There is lime flavor to it, but I don't know.
Great.
Oh yeah, and something cool you can see. This is like pink or purple, right? This is the highlighter fluid I put in there. In like normal light, it's purple pink. If you turn this on, it turns orange. See that? Pink, orange. Something cool. Right? Yeah, that's it. Okay, thank you guys for coming. Hope it was fun.
Bro, make a chunk,